Hello students. So in this video we will see the next part of your straight line. Yesterday we did line passing through a point and parallel to a vector, and we did its vector form and the Cartesian form. Then we did equation of line passing through 2 points we did. Uh, After that we did perpendicularity condition of two lines. What is the condition when two lines are parallel? What is the condition? That we did. And how to change from Cartesian to vector form. So all these things we discussed in the previous video. Now in this video we have the topic shortest distance is also there in your course. Shortest distance between two lines. But before shortest distance between two lines, we have a term, like this is a term. I'll just zoom it. The term is, you see here it is written the term coplanar lines, non-coplanar, coplanar and skew lines. So if the lines are in space and if they lie in the same plane, either they are parallel, or if you extend them they can intersect if they lie in the same plane in 3 dimension. But the lines which are non-coplanar are called skew lines. What do you mean by non-coplanar? Non-coplanar means lines which lie in the different plane. Like these are the three planes you can see. One plane is this xz plane, this is the next plane xz plane, this is a yz plane, and this is the xy plane. If lines are lying in different planes, then they are known as non-coplanar or skew lines. And the topic that you have, this is a very important topic, and you get a 4 or a 5 mark question on this. That is the shortest distance between skew lines. Shortest distance between the skew lines. A very, very important topic, and without going into the derivations, I'll tell you the formula between lines. So the shortest distance between two lines. So first thing that you have to do is, what is the first thing? If lines are given in the Cartesian form, if lines are given in the Cartesian form, we will convert it into vector form. That is the first step. That is, what was the vector form? Vector form was r is equal to a plus lambda b. This was the vector form. Now if the two lines are given, so what we will do, if they are given in Cartesian form, we'll convert it into vector form. So one line will be, these are vectors, a1 plus lambda b1, that is the first line. Second, r is equal to a2 plus lambda b2. We'll convert them into vector form. And what was important in line, yesterday we in the previous video we discussed, it was that line should be in standard form. Coefficient of xyz should be positive and 1. So once you have done that, we write it in the vector form, and the shortest distance formula is given by, it is a2 minus a1 dot b1 cross b2 upon magnitude of b1 cross b2. So this is the shortest distance formula, right? So we'll take up an example. Again, I'll write the formula next. Like say for example, that directly from the exercise we'll take up. And this is a very, very important question. These are the questions from 14th onwards. Question number 14. 14th question says, find the shortest distance between the lines. So I'll just write it again over here. First line is r is equal to I plus 2j plus k plus lambda times I minus j plus k. That is one line. Second line, r is equal to 2I minus j minus k plus mu times 2I plus j plus 2k. Okay, so these are the two lines. Now first line, they are already in the vector form. This is r is equal to a1 plus lambda v1, and the second line r is equal to, this is a2 plus mu times v2, right? So what we do is, from here, what was the formula? Formula for shortest distance was, the formula for shortest distance was a2 minus a1 dot product v1 cross v2 upon magnitude of v1 cross v2. This was the formula. And shortest distance, we always take it as a positive unit. Now a2 minus a1, a2 minus a1, that is, you can just write down the things, a2 minus a1. This is your a2 term, this is our a1. 2i minus I minus j minus 2j will be minus 3j, minus k will make it minus 2. That is a2 minus a1. Then b1 cross b2 is b1 cross b2. Components here are 1, minus 1 and plus 1 it is. So I'll just write it as 1 only. This is 1, plus 1, plus 1. It is in the first row. What do we write? In the first row we write, if you remember the cross product, in the first row we write I, j and k, right? So it will be I, j, k. Then we write 1, minus 1, 1, and components here are 2, 1 and 2. Now expansion of determinant, I hope you all remember. The rule was, for expanding the determinant, if you remember, the rule was, if we expand by the first row, plus, minus, plus, then it is alternate terms, minus. So expanding by the first row, we have to keep different sign, and we always multiply from the left. So this is I minus 1 minus 2, minus 2 minus 1, minus j, keeping this rule in mind, minus j, 1 into 2 is 2, minus 2, plus k, 1 plus 2. So we are getting v1 cross v2 is equal to minus 3i minus 0j plus 3k. This is your b1 cross b2. We will also find the magnitude of this. Denominator of shortest distance is this, that is root 9 plus, which is equal to 3 root 2, right? Now we substitute the values in the formula of shortest distance. So formula says ST, shortest distance, A2 minus A1. A2 minus A1 is from here, J minus 2K. A2 minus A1, I'll write I minus 2J minus 2K A2 minus A1 dot B1 cross B2. B1 cross B2 we have found minus 3I minus 0J plus 3K upon 3 root 2. So this will be, this is minus 3, this is 0, minus 2 plus 3 is minus 6 upon 3 root 2. So finally it is coming out 9 upon 3 root 2, which is 3 upon root 2, or we can write it as 3 root 2 upon 2. This is the shortest distance between the two lines, this units. I hope it is clear. First question. Okay, this is how we do it. Now we move on to the 15th, which is given in Cartesian form, right? So I just rub this side. Look at the 15th question now. Okay, 15th question says x plus 1 upon 7 is equal to y plus 1 upon minus 6, z plus 1 upon 1. That is the first line. Second line is x minus 3 upon 1 is equal to y minus 5 upon minus 2 is equal to z minus 7 upon 1. So first you can see the lines are in standard form. Coefficient of x, y, z are 1 in both the cases. So if I write it into vector form, the first equation will be r is equal to, what is the point over here? Point is minus I minus j, first case, plus lambda times 7i minus 6j plus k. And the second equation r is equal to 3i plus 5j plus 7k plus mu times I minus 2j plus k. So this is the line. Now we have comparing it with the form. First line, the first line is r is equal to a1 plus lambda b1, and this is r is equal to a2 plus lambda b2. Again, what was the formula? Recall the formula. Shortest distance is given by a2 minus a1, b1 cross b2 upon magnitude of b1 cross b2, right? So a2 minus a1, first we'll find out a2 minus a1. a2 minus a1, this is your a2 minus a1, 3i minus I, 3i minus of a1, so it will be 4i, 5j minus j will become plus 6j, and 7 it will become plus 8k. This is your a2 minus a1. Then b1 cross b2, first we write it as I j k, 7 minus 6, 1, 1 minus 2 and 1. When you expand this, I minus 6 plus 2 minus j 7 minus 1 plus k minus 14 plus 6. So this is coming out equal to minus 4i minus 6j minus 14 plus 6, it is, that is equal to minus 8k. This is your b1 cross b2. Now we substitute the value in the formula. Shortest distance, a2 minus a1, 4i plus 6j plus 8k dot minus 4i minus 6j minus 8k upon under root 16 plus 36 plus 64, right? So this is equal to, it is minus 16 plus 36 minus, I am taking a common, plus 64, and it is under modulus. This is equal to 116. Numerator also is what? 116. And distance to final answer will be root 116 units. This is a very important question. Many a times it has been asked. I hope it is clear how to find the shortest distance if it is directly given in vector form and if it is in Cartesian form. So how you have to do it. Now just look at these two, 10th and the 16th and 17th question. I'll just discuss it and then you all can try it out. So the question says, see what does it say? ये बोल रहा है अब यहाँ पे तो see it is directly given in standard form. 16th question, R is equal to A1 plus lambda B1, R is equal to A2 plus lambda B2. What about this question? 17th question, it is given in this form. See, R is equal to 1 minus T I plus T minus 2J plus 3 minus 2TK. तो इसको कैसे करेंगे? When you open it up, I minus Ti Tj minus 2J plus 3k minus 2k. Now we can write यहाँ पे I minus 2j plus 3k, this is 1, and t can be taken out common, right? So plus t, that is a1 plus lambda b1. So t, what is left from here? Minus I from here plus j, and where is the last t? Minus 2tk, so it is minus 2k. This is left. T is there, okay? So this is, if you just see, this is equal to a1 plus p times p1. This is in the standard form. I hope it is clear, the first equation. Similarly, the second equation is r is equal to, see here, यहाँ पे s plus 1i plus 2s minus 1j minus 2s plus 1k. It will be written as r is equal to s plus 1i. I minus j minus k, that is one thing, plus s times s का i, s into i, यहाँ से 2s into j, तो plus 2j, and from here what is s? S we have taken out common, minus 2k. So this is r is equal to a2 plus s times b. Again an important question. So after this I think you'll be able to solve it. Same formula, shortest distance formula, apply it and substitute it. This is your portion of three-dimensional geometry of class 12. So shortest distance, as I repeat again, shortest distance is an important question. You can get a 4-mark question in shortest distance, and remaining questions yesterday only I discussed.